Today, we are going to look at the mammals in the order Monotremata, or the monotremes. These are sometimes called the egg-laying mammals, for reasons that I hope are self-explanatory. There are 5 species alive today, the platypus, and 4 species of echidna. We will also take a look at some of their prehistoric ancestors. As usual, for those interested, there is a document in the description with notable research papers I used for this video, along with the details of the sources for the images used. One definition some people use to define a mammal is that they give birth to live young. While most mammals do, this is not the scientific definition, as there are exceptions to this rule. Scientifically, mammals are defined as having mammary glands to feed young, as well as having hair or fur, 3 bones in their middle ear, and an area of the brain called the neocortex. Monotremes meet all of these definitions, and so are definitely mammals, despite laying eggs more like a reptile or a bird. Mammals are broadly defined in 3 distinct groups, depending on their breeding strategy. Today, we will be dealing with the oldest of these, Prototheria. This only contains one order, Monotremata. This is the monotremes, sometimes called the egg-laying mammals. The other subclass of mammals is Theria, which is further divided into 2 clades. The first is Metatheria, containing the marsupials. There are 7 families of these, spread over Australia and the Americas. They are known for having very small, underdeveloped young, and then placing them into a pouch to rear them up to a size where they can live outside of the pouch. This includes kangaroos, opossums, koalas, wombats, bilbies, and many other iconic animals. The other clade contains all other mammals. This is Eutheria, or the placental mammals. The young are born much more developed than with the marsupials. It is connected to the mother by a placenta, hence the name, which allows it to receive nutrients before it is born. Like I said, literally every other mammal is in this group, from whales to mice, from cheetahs to sloths. If you think of a random mammal, the chance is that it will be in Eutheria. So, returning to focus on monotremes, they may be known for laying eggs, but they are the most primitive living mammals, and so have many other differences to the other mammalian orders. They have different structures in their brain, jaws, digestive tract, and reproductive tract that make them very distinctive. For example, none of the living species has teeth as an adult, although young platypus and some fossil species do have teeth. So this was, obviously, a trait the order used to have but was lost over time. Another example is that they have a single opening for excretion of both feces and urine as well as for reproduction, called the cloaca. This is more similar to a reptile or bird as opposed to other mammals. The monotremes are one of the only groups of animals with electroreception. This is an ability typically seen in fish like sharks and electric eels. All animals give off weak electric signals, as the movement of muscles and neurons in the brain both require tiny amounts of electricity. Animals with electroreceptors can sense these weak signals, allowing them to locate prey even when they cannot see well, such as in caves, at night, or in murky waters. Most animals with electroreception are aquatic or amphibious, as water is a much better conductor of electricity than air, making these signals easier to sense. This is an ability seen in monotremes, with the amphibious platypus having the best electroreception. It has almost 40,000 electroreceptors in its bill. This sense is highly directional, with it having the best senses to the sides and below. Because of this, the platypus will move its head quickly side to side to give it a good sense of its environment. As for the terrestrial echidnas, the long-beaked ones have about 2,000 receptors, while the short-beaked only has 400. The theory is that long-beaked echidnas hunt for invertebrates in tropical forests, so the moist soil conducts electricity decently well. By comparison, the short-beaked echidnas tend to live in drier areas, so find this ability less useful, although the nests of their ant and termite prey is presumably moist enough for them to get some benefits, so they haven't lost the ability entirely. It is believed that electroreception appeared early in the evolutionary record of monotremes, as all living monotremes have this ability to some extent. It is thought that it was present in Teinolophos trusleri, the oldest known monotreme, which used it to find prey in the seasonally dark polar forests of the early Cretaceous. While the living members of Monotremata don't have to deal with those conditions, They are still largely nocturnal and can use it in other settings, such as moist soil or in rivers and lakes, so the ability remained useful and so was retained. There are several families of monotremes only known from the fossil record. Not too much is known about most of them, as their remains are very fragmentary, often consisting of teeth and little else. I have already mentioned the earliest known monotreme, Teinolophos trusleri, but there were others. Kollikodon richii and Steropodon gilmani were both present in the Cretaceous period. They are both notable for being very large mammals at the time, with Kollikodon possibly getting up to a metre long. Mammals of the time were typically very small, which had allowed them to survive in niches alongside the much larger dinosaurs at the time. These are all Australian examples, but there are a couple from South America. One of these is Patagorhynchus pascuali, known only from a few teeth. It was from the late Cretaceous, however, indicating that monotremes did get to South America by travelling over Gondwanaland and were present when that continent broke apart before going extinct in South America later on. I will talk more about that in a minute, but for now let's move on to the first family of extant monotremes. This is Ornithorhynchidae. It contains 3 genera with 5 known species, but only one is still alive today, and that is the platypus. We will move on to the oddity that is the platypus in a minute, but looking at its extinct relatives is also interesting and doesn't take too long, as not too much is known about most of them. Their most distinctive feature is also where the family name comes from, ornithos meaning bird and rhynchus meaning beak. And indeed, their bird-like bill is a very distinctive feature, easily identifying them. Returning to extinct monotremes, the only other one known from South America is in this family. Monotrematum sudamericanum is also known from a handful of teeth, but fortunately platypus teeth are distinctive enough that it can be placed within this family. What is most interesting about these teeth is their size. They are twice the size of the teeth in the other known members of this family. Of course, it is almost impossible to estimate the size of this species just based on a few teeth, but it does suggest that it was much larger than the other known platypus species. The other important thing about the discovery of this species in 1992 was that it made it the first monotreme known outside of Australasia. Their presence on South America strongly suggests that monotremes evolved before the breakup of Gondwanaland during the Cretaceous period, a theory later confirmed when Patagorhynchus fossils were discovered. Gondwanaland was a supercontinent and was the last time Australia, Antarctica and South America formed a single landmass, allowing for monotremes to travel from one to the other, and so be found on both, at least in the fossil record. Of course, no living monotremes survive in South America, and they remain far more common on Australia even in the fossil record. They must have survived on South America for a time, however, as the fossils of Monotrematum sudamericanum are from after the extinction of the dinosaurs, about 66 to 56 million years ago. The other extinct genus in this family is Obdurodon. This has 3 species, O. insignis, O. dicksoni, and O. thoroughd's child. Depending on the species, they lived between 28 to 50 million years ago. Most of them are thought to look quite similar to the modern-day platypus, except that the adults do have teeth. It is thought that they were predators that hunted in the water column or on the surface, unlike the modern platypus which feeds on the lake bed. I do want to take a minute to look into the name that the third of those species was given, Obdurodon thorogh's child. The species name is derived from an Aboriginal story about the creation of the platypus. Thorogh was a female duck who disobeyed her parents and swam downstream. She was caught and, trying not to trigger anything with YouTube, let's just say that she was forcibly mated by a water rat. She returned to the other ducks and laid an egg much like them, but when it hatched, it contained the first platypus, a creature with the bill and webbed feet of its duck mother and the fur and teeth of its rodent father. That story leads us into the bizarre theories the early Europeans had when they first saw a platypus. The first one sent back to England was assumed to be a hoax, as it was too bizarre to be a real animal. Even once it was accepted as a real animal, the idea that it laid eggs was rejected, ignoring both Aboriginal knowledge and the physical evidence. It was definitely a mammal, as it was found to have mammary glands, but even this was disputed, despite having skins with these glands present. So, the modern-day platypus, Ornithorhynchus anatinus, is an egg-laying mammal found along the eastern coast of Australia and throughout Tasmania. The name platypus comes from Greek meaning flat-footed. We have already discussed many of their unique adaptations. Monotremes may be one of the very few mammals with electroreceptors, but the platypus are by far the most sensitive at detecting electrical signals. This makes sense given their semi-aquatic lifestyle, and water is a much better conductor than air or soil. They likely use this to detect their prey, small invertebrates and fish, on the lake bed where visibility can be low due to sediment or dark due to vegetation. Just to add another oddity, the platypus is one of the very few mammals known to be venomous. The males have venomous spurs on their hind legs. Juvenile females do have vestigial spurs, but these are lost before they are a year old. It is believed that the spurs may have played some role in defending them against predators in prehistory, but platypus have no modern-day native predators, so this trait is only retained in males for fighting during the breeding season. The venom causes intense localized pain in humans, and, at the least, temporarily disables competing male platypus. Only one platypus has been recorded as dying due to this venom. It was in captivity and the result of being envenomated multiple times. Platypus are considered near threatened by the IUCN, but are declining in much of their range. In South Australia, for example, they are endangered and considered almost extirpated. The main threat to them are human modifications to waterways and water flow. Many waterways have had vegetation removed from the riverbanks, or are polluted due to urbanization or agriculture. Some have even had the water flow of the rivers altered. The breeding season for platypus is assumed to occur when food is most plentiful, like has been proven the case for echidnas. The male and female perform a courtship dance on the surface of the water, led by the female. She will then construct a burrow where she lays 1 to 3 eggs. These hatch after 10 days, and the puggles lack any fur. As an aside, I have just learned that baby monotremes, both platypus and echidnas, are called puggles, and that is such a cute name I just had to include it somewhere in this video. The puggles stay in the burrow for about 3 to 4 months, feeding on milk from their mother. After this, they emerge from the nest and are fully weaned within days, feeding on an adult's diet of aquatic invertebrates. The platypus is only part of this video, so now let's finally return to the other branch of living monotremes, the echidnas in the family Tachyglossidae. The unusual common name has 2 frequently suggested origins. The first is from Greek mythology, as Echidna is the mother of monsters quite literally, with some of her more famous offspring being Cerberus, the 3-headed dog that guarded Hades, and the Chimera, a fire-breathing lion-goat-snake hybrid creature. Echidna herself was part woman and part snake, and so the name was possibly given to the animals because they have mammalian and reptilian qualities. The other explanation is a misspelling of the Greek echinos, meaning hedgehog or sea urchin, which bear striking similarities to echidnas. There are 4 living species of echidna, and 3 that are extinct. Echidnas lay eggs like all monotremes, but interestingly have a pouch similar to a marsupial. They deposit their eggs into the pouch where their young hatch. The puggle have an egg tooth, similar to some reptiles, to break through the shell. They then remain in the pouch for up to 3 months, suckling on milk from the mother. The mother will then dig a nursery burrow where she leaves the young while she forages. The young can remain in the den for up to a year before venturing out on their own. Echidnas earn their other common name of spiny anteater by being covered in hedgehog-like spines. The anteater part of the name refers to the short-beaked echidna's preferred diet of ants and termites, but the other species prefer worms and beetle larvae, so the name is not entirely accurate for all of them. Starting with the extinct species, Murrayglossus hacketti is believed to be the largest monotreme to have ever lived. Estimating its size is difficult, as it is only known from a few bones, but current estimates suggest it reached lengths of around 1 metre or 3.3 feet. It was only moved into its own genus in 2022, and before that was placed in the genus Zaglossus, alongside the living species of long-beaked echidnas. It is believed to have lived around 40,000 years ago, and there is Aboriginal cave art that may possibly depict it, although it could also be one of the extant long-beaked echidnas instead. The other extinct genus is Megalibgwilia, which has 2 species, M. owini and M. robusta. These are the oldest known echidnas, going extinct around 50,000 years ago. They are believed to have been similar in size to the modern-day western long-beaked echidna, so that is up to about 0.5 metre long or 1.5 feet. They did have slightly longer forelegs than the modern echidnas though. It is believed that these species went extinct when Australia began to dry out, transforming into the desert that much of the landmass is today. Moving on to the echidnas that are still alive today, we will start with the short-beaked echidna, Tachyglossus aculeatus. This is the only member of its genus, and is by far the most common of the echidnas. It is listed as least concern, and is found throughout Australia and in parts of New Guinea. There are 5 subspecies, which live in different geographical regions, but have other noticeable differences, like the length of its hair or its quills. It has strong front legs and claws, which allows it to burrow quickly into the ground, but also rip apart logs and move stones. Likely as an adaptation for burrowing, it has surprisingly high tolerance for conditions with low oxygen and high carbon dioxide. They are between 30 to 45 centimeters or 12 to 18 inches in length, but their snout alone is around 7.5 centimeters or 3 inches. Unsurprisingly, this snout is specialized for its feeding habits. As I said before, short-beaked echidnas eat ants and termites. Its tongue is sticky, causing prey to get stuck to it. The tongue can be stiffened by blood flow, allowing it to penetrate wood and soil to find prey. When the tongue is retracted, the ants are caught on the backwards facing teeth in the snout, allowing them to be removed from the tongue and ground up before being swallowed and digested. The tongue can move very quickly, and has been measured at moving in and out of the snout over 100 times in a minute. This speed and specialization of the tongue and mouth allow it to eat very quickly. A 3-kilogram echidna has been recorded eating 200 grams of termites within 10 minutes. When threatened, echidnas curl into a ball to let their spines protect them. Unfortunately, their most common threats are not ones that their spines can protect them from. Motor vehicles and habitat loss are the largest causes of decline. They are still fairly tolerant to land clearance, as long as fallen logs are left in the area, as their main requirement is a source of ants or termites. As long as they are still in the area, echidnas can tolerate environmental changes fairly well. Although easy to keep in captivity, short-beaked echidnas are notoriously difficult to breed in captivity, with no or few zoos producing young that survive to maturity until the last 10 years. While not a major concern for the short-beaked echidna, given that it is still relatively common, it is concerning for the outlook of its long-beaked relatives, many of which are critically endangered. The other genus of echidnas has the remaining 3 living species. Much less is known about these than the Australian monotremes, as they are found in a more remote part of the world and are much more rarely seen. Even when tracking them in the wild has been attempted, it has been hampered as their arrangement of spines are different to that of the short-beaked echidna, so transmitters used to track those cannot be attached to the long-beaked echidnas. It was thought that the long-beaked echidnas were a single species until they were separated into their current classification in the late 1990s. The first of these is the eastern long-beaked echidna, Zaglossus bartoni. It is the most common of the long-beaked echidnas, but is still rated as vulnerable by the IUCN. This is actually an improvement though, as until 2016 it was listed as critically endangered. It is found in the highlands of New Guinea, in both Papua New Guinea and Indonesia. It is found up to 4,000 meters, which is the top of the highest peaks in the region. It lives in the tropical highland forests and subalpine environments. They have been shown to have a wide variety of home ranges, between 10 to 168 hectares, and this variation does not appear to be based on age, gender, or size. They use their long snout to find and eat insect larvae, ticks, and earthworms. They poke their long snout into the soil to find their prey, leaving impressions in the ground. Depending on how deep they have to go to find prey, these impressions are a little different, whether it is only a nose poke, or if they have to press their head firmly against the ground, leaving its impression on the soil. Alternatively, they may use their tough front claws to dig for a little first, so that they can poke their nose in deeper. As for how they locate their prey, it likely comes back to the electroreception we mentioned earlier. While not as sensitive as platypus, they do still have plenty of electroreceptors, so possibly use these to work out where to dig for worms. They do not only get their prey from the ground, however, as logs have been found with claw marks, suggesting that echidnas may break into fallen wood to find suitable food, so likely they also eat grubs and other wood-boring insects. It is most threatened by deforestation, but locals and feral dogs will sometimes hunt them. There are 4 subspecies, which are each found in different locations. Like platypus, they have spurs on their hind legs, but unlike platypus, these are not venomous. The females lose these spurs as they get older, but males retain them, so they likely have some role in reproduction. The next species is Attenborough's long-beaked echidna, Zaglossus attenboroughi. As you might have guessed, it is named in honour of Sir David Attenborough, the wildlife biologist and documentarian. It is critically endangered and has only been found in the Cyclops Mountains in the northern part of the Indonesian half of New Guinea. It is the smallest species of long-beaked echidna, being a similar size to the short-beaked echidna. They are not social, only coming together to reproduce in July. The female lays eggs in her pouch after about 8 days, and the young stay in there for 8 weeks or until their spines start to develop. As with the other long-beaked echidnas, they are nocturnal and will roll into a spiny ball when threatened. Attenborough's long-beaked echidna was described from a single specimen obtained in 1961, and no other specimens have been collected since. It was assumed to be extinct until the distinctive holes formed by its nose poking into the ground were found in 2007. In 2023, this species was finally seen again, with one being captured on a trail camera. This was the first time one had been seen in over 60 years. They are assumed to be threatened, partly due to the rarity of its sightings, but also because of the deforestation occurring within its known range. The last species of living monotreme is the western long-beaked echidna, Zaglossus bruijnii. It is found in the far western part of New Guinea, and is also considered critically endangered. It prefers highland forests and can be found up to 2,500 metres or 8,200 feet above sea level. There is actually some dispute among experts as to whether this species could be found on mainland Australia, and the argument stems from an individual in the British Museum of Natural History. This individual was collected in 1901, and its label states its place of collection as the Kimberley region of northwest Australia. While commonly accepted as having the wrong location mistakenly recorded, some scientists believe that this is too improbable, and it is more likely that the species did, or possibly still can be found in poorly surveyed forests in northwest Australia. It has even been argued that if it has gone extinct locally, then reintroduction might be a possibility. The major threats to western long-beaked echidnas are habitat loss and hunting, although commercial hunting has long been banned by the Indonesian government, but they do still allow traditional hunting. I hope you have enjoyed this video. The monotremes are a fascinating group of early mammals with adaptations seen on few other animals. Electroreception and venom are incredibly rare among mammals, and laying eggs is unique. There is still plenty more to learn about the monotremes, and especially the elusive long-beaked echidnas, but I do hope that you have learned something new today. Thank you for listening, and feel free to suggest another group of animals you want to see me cover in the comments.